solve linear systems by graphing. Graph each system of equations. Clearly state what the solution is for each. Number 1, x plus y equals 5. 3x plus 3y equals 15. First thing we have to do is get these in slope-intercept form, which is what we wanted in our last unit. So we're trying to get y by itself, so we're going to subtract x from both sides. We cannot combine 5 and negative x because they're not like terms, so that just gives us y equals negative x plus 5. When we graph that, we're going to go up to 5 on the y-axis. And then we go down 1 to the right 1. Nope, down 1. Yeah, down 1 to the right 1. Down 1 to the right 1. Anytime you go down, you're going to go over to the right until you have enough to make a line. And for my second, I've got to subtract 3x from both sides. 3y equals negative 3x plus 15. Divide by 3. Negative 3 divided by 3 is negative 1, so that's going to be negative x. 15 divided by 3 is 5. So when I graph that, I start at 5 on my y-axis, go down 1 to the right 1, and I see that I have graphed that on the same line, so I have infinitely many solutions. Number 2. These are already in y-intercept form, so all I have to do, slope-intercept form, so all I have to do is graph them. We start with our y-intercept. That's at 6. So we're going to go up to 6. Our slope is 3/2. Slope is rise over run, so that means we're going to go up 3 to the right 2. Since I can't go up 3, I'm going to go down 3. But if we're doing the opposite of what the numerator tells us, then we have to go to the left. We're going to go to the left 2. Down 3 to the left 2. That way I still get a positive slope. And for the other equation, I start at 4. 1, 2, 3, 4. I'm going up 1 to the right 2, or down 1 to the left 2. And we see that they cross at negative 2, positive 3. That is our solution. Remember, if it has one solution, then you have to state exactly what that solution is. All right, number 3 and 4. We have to put these in slope-intercept form. So we're trying to get y by itself. I'm going to add 3x to both sides. Y equals 3x plus 1. So I'm going to start at 1 on my y-intercept. My slope is 3, so I'm going up 3 to the right 1. Up 3 to the right 1. I can also go down 3 to the left 1. This is my graph. For my second equation, y equals 3x minus 4, we're going to start at negative 4 on our y-axis. And then our slope is 3, so we're going up 3 to the right 1. When you have two equations that have the same slope, if they do not have the same y-intercept, then your answer will be no solution. But of course, if you have the same slope and the same y-intercept, that's when it's infinitely many solutions, just like with number 1. Number 4, y equals negative x minus 2. We're going to start at negative 2 on our y-axis. Our slope is negative 1, so we're going down 1 to the right 1. Here's our graph. And for our second equation, we have to subtract 2x from both sides. Negative 3y equals negative 2x minus 9. I have to get y by itself, so if I'm multiplying negative 3 and y, I'm going to divide by negative 3 on both sides. y equals negative 2 over negative 3 is just going to be 2/3. We're going to leave that in fraction form. Negative 9 divided by negative 3 is positive 3. So we're going to start at positive 3 on our y-axis, and we're going up 2 to the right 3, or down 2 to the left 3. And we cross that negative 3, 1. So we have one solution. That solution is negative 3, 1. All right, number 5, checking solutions of systems of equations. Decide whether the ordered pair is a solution of the system. For 5 through 8, you do not have to graph these. All you have to do is plug in x and y for your x and y and see if you get a true statement. So we have 3x minus 2y equals 11. My x is 5, my y is 2. 3 times 5 minus 2 times 2 equals 11. 3 times 5 is 15. 2 times 2 is 4. And 15 minus 4 is 11. 11 equals 11. So 5, 2 is a solution of the first equation. So now we'll check the second equation. Negative x plus 6y equals 7. The opposite of 5 plus 6 times 2 equals 7. 6 times 2 is 12. And when you're adding signs, numbers with different signs, you have to subtract, keep the sign of your highest number. That's your integer rules. So negative 5 plus 12 is 7, and 7 does equal 7. So yes, that is a solution. Number 6 is negative 2, 1, a solution for 6x minus 3y equals negative 15. 2x plus y equals negative 3. 6 times negative 2 minus 3 times 1 equals negative 15. 6 times negative 2 is negative 12. Negative 3 times 1 is negative 3. When you're subtracting, you have to do additive inverse. Negative 12 plus negative 3 is negative 15, which equals negative 15. Our second equation, we have 2 times x plus y equals negative 3. 2 times negative 2 is negative 4. And negative 4 plus 1 is negative 3. That does equal negative 3, so yes, that is a solution. Number 7, we have 4x, x is 3, plus y, which is negative 6, equals 6. 4 times 3 is 12. 12 plus negative 6 is 6. So it works for our first equation. For our second equation, 3 plus 3 times y, y is negative 6, equals 15. 3 times negative 6 is negative 18. And 3 plus negative 18 is negative 15. That does not equal 15. So no, that is not a solution for that system. And number 8 is 4, negative 1, a solution of negative 5x plus y equals 19, x minus 7, y equals 3. We have negative 5x, 5 is negative 4, plus y, which is negative 1. Negative 5 times negative 4 is 20. 20 minus 1 is 19. So it works for our first equation. For our second equation, we have negative 4 minus 7 times negative 1 equals 3. Negative 7 times negative 1 is positive 7. Negative 4 plus 7 is 3. So yes, that is a solution for that system. Alright, solving linear systems by substitution. You must be able to demonstrate solving a system using this method. So on this one, we have to use substitution. If it tells you to use substitution, then you have to use substitution. X equals 5y, 2x plus 3y equals negative 13. We have already isolated a variable. So all we have to do is substitute what x equals in for x in the other equation. 2x, x is 5y, or x is equal to 5y, plus 3y equals negative 13. 2 times 5y is 10y. I can combine like terms. 10y plus 3y is 13y. And when I divide by 13 on both sides, I get that y equals negative 1. I plug that back into one of my original equations, x equals 5y, and we found that y is negative 1. 5 times negative 1 is negative 5, so x equals negative 5. So my ordered pair is negative 5, negative 1. Number 10. I need to get a variable by itself because I do not have that. I always pick the variable that has a coefficient of 1 or negative 1. So I'm going to isolate a. In order to do that, I add 6b to both sides. Those cancel out. A equals 6b minus 6. So I'm going to plug this in for a in the other equation. 2a, which is 6b minus 6, plus 3b equals 3. 2 times 6b is 12b. 2 times negative 6 is negative 12. Write the rest of your equation. 12b plus 3b is 15b. Bring everything else down. Add 12 to both sides. 15b equals 15. Divide by 15. b equals 1. Plug that back into one of your original equations. A minus 6 times 1 equals negative 6. Negative 6 times 1 is negative 6. I add that to both sides, and I get a is 0. So my solution is 0, 1.